Let's look at applying the formula of the shapes to find the missing values, such as the diameter or the radius or a length. So example 1, we've got a cylinder and it must meet the requirements of having a volume of 1200 cubic centimeters, and it needs to have a length of 25 centimeters. So what radius must the cylinder have? So the way we do this is we know the volume is equal to the area of the cylinder, so the circular area, multiplied by its length, or in this case the height. So we can rearrange this formula to give us the area, and it will be area is equal to the volume divided by the height. We know the volume and we know the height, so we can plug those in and we get 48 centimeters squared. We also know that the area is equal to pi r squared, the famous circle area formula. So what we can do here is, because we know the area, all we need to find out is r. So we can use this formula and change the subject of the formula for r. So we'll do this bit by bit. So let's first of all put this 48 centimeters squared into this formula. So we're replacing a with 48 centimeters squared. And now what we want is we want this right hand side to be r on its own. So we're first of all going to multiply this side by pi, so the pi's cancel out. And because we do it to this side, we also have to do it to the other side. We have to do it to the left hand and the right hand side. Now the pi's cancel out, and we're left with r squared is equal to 48 over pi. 48 over pi is equal to 15.28. Now we've got r squared, so to get r on its own and isolate r, we can take the square root of r squared. And because we do it to the right hand side, we also have to do it to the left hand side, like this. The square and the square root cancel out, and we're left with r is equal to 15.28, the square root of that. And that comes to 3.9 centimeters to one decimal place. Okay, so we've found the radius of 3.9 centimeters, which meets the requirements of having the volume of 1200 cubic centimeters with a length of 25 centimeters. Example 2, now we have a sphere, and this sphere must meet the requirements for having a volume of 4,300 cubic centimeters. So what diameter must the sphere have? Alright, so what we're going to do is we are going to use the volume of a sphere formula. So we've got 4 over 3 pi r cubed. So what we can do is we can recognize that this is given us in terms of radius, but we know that the diameter is equal to 2 times the radius. So what we can do is we can find the radius with this formula, then we'll multiply it by 2 to get the diameter. So let's plug the volume into this equation, and now just like the last time, we want to get r on its own. So what we can do first of all is we can multiply by pi to eliminate pi from the right hand side, but we also have to divide by pi on the left hand side. So we're dividing both sides by pi. Now the pi's cancel out on this side, and 4,300 divided by pi is 1,368.7. Now this whole term is being divided by 3, so what we can do is we can multiply both sides by 3. Now these 3's cancel out, and on the left hand side that comes to 4,106.2 to one decimal place. Now we can isolate r cubed by dividing both sides by 4. These 4's cancel out, and on the left hand side we get 1026.5. Now that's equal to r to the power of 3, so we take the cube root of both sides to get r on its own. And now we have a cube root of 1026.5, which, using our calculator, we get 10.1 centimeters to one decimal place. And now that's the radius, but we're looking for the diameter, so we multiply that by 2, and what we get is a diameter of 20.2 centimeters.